Hello students, welcome to today's special session. All of you are on the top gear for the preparation of board examinations, aren't you? You attend class, take lot of notes, watch videos, learn something, right? While preparing, have you ever thought about the weightage of each chapters? I mean the mark distribution of each chapters? The blueprint of past year's board question papers? What are the relevant and irrelevant questions from your textbook? What is the weightage of easy type, average type, and difficult type questions? No, you may not have time to look into these technical aspects of board examination preparations. Add some elements of smart work along with hard work, which will fetch you 100% success. So in this video, we will learn how to score minimum 16 marks out of 80 marks from the section A of your physics syllabus. That is chapters force, machine, work, power and energy. And let's see how the same pattern has been continued for the last 10 years. Let us have an analysis. Watch the video till the end without skipping and develop a smart approach towards your studies. Let's first analyze year 2018 board question paper. As you can see on the screen, there are 3 questions of 2 marks each in section 1, which belongs to the first 3 chapters of your textbook. This pattern remains same for all the years. I assure you 6 marks short answer type questions from section 1. There are 3 questions and this pattern remains same for all the years. Now let us solve it. Now let's look at section 1, the first question. How many questions are there and how many marks are there? Please check the question paper. Question number 1. State and define the SI unit of power. What is SI unit of power? SI unit of power is watt. Okay, so you wrote watt, 1 mark is awarded. And what is the second part? Read the question thoroughly, don't forget to define it. Define 1 watt. 1 watt means 1 watt is equal to when 1 joule of work is done in 1 second. The power spent is said to be 1 watt. So you got 1 more mark. So total 2 marks. Alright? Okay. Now question number B, first part. State the energy changes in the following cases while in use. In case of an electric iron. In electric iron, what is the energy changes? All of you may be knowing it. Of course, it is electrical energy is being changed into heat energy. All right. And second part, don't miss any sub questions. Read the questions very thoroughly. In a ceiling fan, what is the energy changes taking place? So in ceiling fan, question number 2, of course, again what we are giving as input, electrical energy. In ceiling fan, we are giving electrical energy as the input, and what we are getting as output. So electrical fan does some mechanical energy, mechanical work. Mechanical energy. Alright. So 1 mark plus 1 mark, again you are getting 2 marks. Alright. Okay. Then what is the C part? C, first part. The diagram, it's a diagram based question. The diagram below shows a lever. You have to identify the lever. To which class of lever does it belong? So you can see that in the lever, the load is at the middle. Load is at the middle. This is the fulcrum and this is the effort. So load is at the middle. Since load is at the middle, it belongs to which class of lever? It belongs to second class. Second class. Just write second class. Alright? Okay. Now the question number 2. Without changing the dimensions of the lever, what are you doing there? If the load is shifted towards the fulcrum, you are shifting the load towards the fulcrum. Okay. What will happen to the mechanical advantage of the lever? You know that mechanical advantage of the lever is equal to effort arm upon load arm. Remember all the formula. What happens to load arm here? So the load arm decreases. Alright. The load arm decreases. Then what happens? Mechanical advantage increases. So you can write here, since load arm decreases, mechanical advantage increases. Mechanical advantage increases. Alright. So 1 mark, total you are getting 2 marks. Okay, very simple. So remember the concepts of power, its definition, its unit, energy transformations, and the class of lever. You should be able to identify the class of lever. So 6 mark is sure, it's certain for section number 1 from force, work, power and energy. Alright? Okay. Now let's go to section 2, question number 5. So sections 2, question number 5 carries 10 marks. 3 plus 3 plus 4, total 10 marks. And this pattern remains same. And you can expect 10 marks from the first 3 chapters of the physics textbook. That's from force, work, power and energy and machines. It can be some diagram based questions, it can be some numericals or some definitions or unit, but 100% 10 mark is sure. All right, so let us go to the solving session. Okay, section 2, question number 5. A1, derive a relationship between SI and CGS unit of work. And second one, a force acts on a body and displaces it by a distance s in a direction at an angle theta with the direction of force. What should be the value of theta to get maximum positive work? All these things we have already solved in the session, discussed in the session in detail. Please watch our backup videos and clear your doubts. So since first one, what is the relationship between SI and CGS unit of work? Derive. You have to derive it, not to state it. Then you have to show all the steps. Okay, so since work is equal to force into displacement, work is measured in 1 joule, that's equal to 1 Newton into 1 meter. All right, 1 Newton is equal to 10 to the power 5 dyne, you know it. 1 meter is equal to 10 to the power 2 centimeter, you know that. So 1 10 to the power 7 dyne centimeter. Okay, so 1 joule is equal to 10 to the power 7 dyne centimeter is equal to erg. So 1 joule is equal to 10 to the power 7 erg. So you are getting, if you are showing all these steps, you are getting 2 marks. All right, so practice this kind of question. And what is the second part? A force acts on a body and displaces it by a distance of s in the direction at an angle theta with the direction of force. What should be the value of theta to get the maximum work? So we know that W is equal to Fs cos theta. Write the formula. Okay, for maximum work, cos theta should be 1, right? Cos theta should be equal to 1 for that, or theta should be 0, cos 0, 1. Okay, so you will be awarded 1 mark if you are showing these steps. All right, yes. So moving on to the next question, question number 2, B1. It's a numerical question. Since all the first 3 chapters are numerical oriented lessons, you have to prepare, you should expect a numerical for section 2. So definitely a numerical can be asked and you should be prepared for that. So a half meter rule, not 1 meter rule, is pivoted at the center. Okay, you can see at the fulcrum, and 20 gram force and 12 gram force being suspended at a perpendicular distance 6 centimeter and 10 centimeter respectively as shown in the figure. Have a close look at the figure. So what is the question? Which of the 2 forces acting on the rigid rod cause clockwise moment? So clockwise moment in this direction, right? So clockwise moment is produced by which one? Of course, the 12 gram force. 12 gram force rotates rod clockwise. All right, so 12 gram force will produce a clockwise moment. All right, yes. Is the rod in equilibrium? Second part, is the rod in equilibrium? In order to calculate the rod in equilibrium, you have to calculate the clockwise moment and anti-clockwise moment. What is the clockwise moment? Clockwise moment is equal to force into 12 into perpendicular distance. Okay, that's equal to 120 gram force centimeter. What is the anti-clockwise moment? Anti-clockwise moment is equal to force into perpendicular distance 20 into 6, that is equal to 120 gram force centimeter. So we can say that clockwise moment and anti-clockwise moment are equal. We can say that rod in equilibrium. Okay, clear? Yes, you are getting 1 mark here, 1 mark here, so total 2 mark. Again one more question is there, the third question. Okay, what is the third question? On reversing the direction of 20 gram force. If you are reversing this 20 gram force you are bringing here, what is the magnitude of resultant moment of the forces on the road? So if you are bringing 20 gram force here and 12, keep it here. Okay, they are asking about only 20 gram force, not about 12 gram force. You are bringing 20 gram force, bringing here. All right. Okay. So what will happen? Total clockwise moment will be, so there won't be any anti-clockwise moment. There will be an addition to the clockwise moment since you are bringing 20 gram force to this side. So the total clockwise moment will be equal to how much? First of all, 20 gram force, 20 into 6, okay, plus you are bringing 20 gram force at the same distance here. Remember that is distance remains same, you are just reversing it. So 20 into 6 plus 12 into 10. 12 was already there, so no change. So 120 plus 120, you are getting it as 240 gram force centimeter. All right. So the answer is complete. You are getting one more mark. So total is 3 marks. All right. So 3 marks, part is over. You got full mark. All right. So moving on to the last question of question number 5, that is C part, which carries 4 marks. Draw a diagram to show a block and tackle pulley system having velocity ratio 3. So velocity ratio 3, making the direction of load, effort and tension. So velocity ratio is equal to 3. So how many pulleys will be there? Of course there will be 2 pulleys, and you have to draw a complete diagram. You have to show the support. If you are not showing the support, 3 pulleys are there, 2 pulleys in the upper block and 1 pulley should be in the lower block. All right. Yes, I can draw like this. Only, okay, 2 pulleys in the upper block and 1 pulley in the lower block. All right. Yes, how can you pass the hook? From here, from the hook of the lower block. So completed. Now the free end, we got it, the load being attached at the lower block. All right. Load direction is acting downward, the effort is being applied in the downward direction, tension acting along the string, tension T in the upward direction. All right. Okay. So the diagram is complete. Velocity ratio 3, number of pulleys should be equal to 3. When number is 3, 2 should be in the upper block and 1 should be in the lower block, because number of pulleys in the upper block should be more than that of number of pulleys in the lower block. Either should be equal or should be more than that. Okay. Yes. So you are getting here 1 mark. What is the second part? The pulley system lift a load of 150 Newton. When an effort of 60 Newton is applied, find its mechanical advantage. Mechanical advantage, so simple. L upon E. So L upon E is equal to 150 divided by 60. You are getting it as 2.5. Mechanical advantage 2.5. All right. So it should get 2 marks. All right. Yes. So the third part is that, is the above pulley system an ideal machine or not? Because for a pulley system to be an ideal machine, the mechanical advantage should be equal to velocity ratio. Actually, what is the mechanical advantage here? 2.5. So 2.5 is less than 3. That is the velocity ratio. So this pulley system is not, this pulley system is not ideal, because since the mechanical advantage is less than the velocity ratio. Give the reason also. It will be more impressive. Though it is not asked, always give the reason and impress the examiner. All right. So you are getting, in this section you are getting 4 mark. So we have covered 4 plus 3 plus 3, that is 10 mark from the section 2, that is question number 5. So practice pulley based questions, some numericals related to meter rod, principle of moments, and the power, the concepts of power and the formula for power. All right. Yes. Now let's check what happens to year 2K19 question paper. Again, there are 6 marks from the first 3 chapters of your physics syllabus, and you can find on the screen, the same type of questions are being asked there. The same topic is being tested there. Alright, like simple machines, unit of energy, kinetic energy, and identification of levers, which class of lever, a diagram based question, etc. You can see the same topic, the same type of questions are again and again being asked there. So these topics are very important. Now let's go to the first question of section 1A, question number 1A. What's the question? A diagram based question, and you have to identify. The diagram below shows a claw hammer used to remove a nail. To which class of lever does it belong? You have to identify which class of lever. Claw hammer. Claw hammer, look at the diagram carefully. The fulcrum is at the middle, right? So you might have learned about it. So it belongs to class 1 lever. I can write class 1 lever. Alright? Yes. So what is the second part of the question? Give one more example of the same class of lever mentioned by you in 1 for which the mechanical advantage is greater than 1. So the class remains same. So you know that in case of class 1 lever, the mechanical advantage can be greater than 1, less than 1, or equal to 0. Alright. So in metal cutter, or we can say that in shear or metal cutter or shears used to cut metal whose mechanical advantage is greater than 1. So if you write this like answer 1 plus 1, you are getting it as 2 marks. Alright? Yes. Okay. Now question number B, the first part. Two bodies A and B have the same masses in the ratio 5:1 and the kinetic energies are in the ratio 125:9. Find the ratio of their velocity. A question related to kinetic energy. So you know that mass of the body A and mass of the body B given as 5:1. Alright. And the kinetic energy ratio of the body A and kinetic energy of the body B, it is given 125:9. So of course you have to take the velocity of body A to the velocity of body B. That will be equal to, you know that kinetic energy is equal to, I can write K is equal to half mv squared. Alright. You have to take the velocity. So velocity is equal to square root of, I can write Ka mb. Kinetic energy of the body A into mass of the body B divided by kinetic energy of the body B into mass of body A. So that's equal to kinetic energy of body A 125 divided by kinetic energy of the body B 9 into mass of the body B 1 divided by mass of the body A, it's equal to 5. So on solving, so you are getting it as under root 25/9. Alright, that's equal to root 5 and 3, 5/3. So this is the answer. So you must know the formula and just a simple mathematical operation, you can calculate the ratio of kinetic energy there. Alright, so velocity of body A to the velocity of body B, but you must know the formula of kinetic energy. So what is the next third part? This question carries 2 marks. What is the third part of the question? Name the physical quantity which is measured in calorie. Of course, you know it, heat energy, right? Heat energy. Okay. How is calorie related to SI unit of this quantity? So 1 calorie is equal to 4.2 joule. So that is the relation between calorie and joule. So heat energy and 1 calorie is equal to 4.18 joule or approximately 4.2 joule. So 2 marks. So total 2 plus 2 plus 2. You are getting 6 mark. And what do you conclude from this question number 1? 2019 question paper. The same type of questions are asked here. You have to remember the classification of the lever, identify the lever, kinetic energy, concept of kinetic energy and its formula, and simple units and definitions of energy. So these types of questions are asked. These topics are very important. Please focus on these topics. Now let's go to section 2, question number 5. Again 10 marks from first 3 chapters of your physics syllabus. See, look at the question. Look at the pattern of the question. Compare with the 2018 question paper. The same type of questions are again asked from the same topic. A diagram based question from pulley system, and a diagram based question from principle of moments to find out the mass of the meter rule. Okay, and a few conceptual questions from mechanical energy, that is potential energy and kinetic energy. So these topics are very important. It reminds us of that these topics are very important. Now let's solve the question number 5. First part of the question. This question carries 3 marks. A body of mass 10 kilogram is kept at a height of 5 meter. It is allowed to fall, free fall, and reach the ground. What is the total mechanical energy possessed by the body at a height of 2 meter, assuming it is frictionless? So the total mechanical energy possessed by the body will be equal to total potential energy at a height h is equal to 5 meter above the ground. Alright. So I can write E is equal to total mechanical energy is equal to mgh, that is equal to mass 10 into g is given as 10 into height 5. So you are getting it as 500 joule. So that will be the total mechanical energy possessed by the body at a height of 2 meter. That will be equal to total potential energy at a height of 5 meter, because energy is not destroyed there. No energy is being destroyed there. Alright. What is the kinetic energy possessed by the body? Second part. Just before hitting the ground. Just before hitting the ground. What is the kinetic energy? Just before hitting the ground, kinetic energy will be equal to the potential energy. That's equal to 500 joule. Again, so simple. So if you remember the law of conservation of energy and the concept, you can easily attempt this question. 1 plus 1 plus it carries 3 marks. Okay, that's equal to total 3 marks you are getting. Alright. Okay. Now let's solve the second question of question number 5. Again it carries 3 marks. You can see a uniform meter rule suspended as shown in the figure. You can see a mass of 40 gram force suspended at the 5 centimeter mark, and it is balanced at fulcrum is at 30 centimeter mark. You have to calculate the weight of the meter scale. You have to calculate the weight of the meter scale. So calculating weight of the meter scale is an important question. So what is the weight of the meter scale? Weight will be always acting at the center at the 50 centimeter mark, right? Okay. So by the principle of moments, you can write by principle of moments, clockwise moment is equal to anti-clockwise moment. Alright? Yes. So diagram is clear. So what is the distance? 50 minus 30 from the fulcrum, it is 20 centimeter. Alright? Okay. What is the clockwise moment? Force into, we don't know what is the force, W into some unknown weight of the meter rule into what is the distance from the fulcrum? 20 is equal to, what is anti-clockwise moment? 40 gram force producing an anti-clockwise moment. Force into perpendicular distance, force into, what is the distance here? 30 minus 5, that is 25. Okay, so W is equal to 40 into 25 divided by 20, that is equal to 2, that is equal to 50 gram force centimeter. Write the unit correctly. It's 50 gram force centimeter, that is the weight of the meter rule. Alright. Yes, what is the second part? Which of the following option is correct to keep the ruler in equilibrium when 40 gram force weight is shifted to 0 centimeter mark? F is shifted towards 0 centimeter, or F should be shifted towards 100 centimeter. So in order to balance this, F should be shifted to 0 centimeter mark. Alright. So F fulcrum should be shifted to 0 centimeter mark. Alright. So this question carries 3 marks. A diagram based question related to principle of moments or finding the mass of a meter rule. Alright. Very, very important. Focus on this concept. Let's move on to the last question of this question number 5, section 2. Again, it's a diagram based question from the pulley part, which carries 4 marks. The diagram is given there. Copy the diagram and mark the direction of tension on each strand of the string. The load is acting downward, tension is acting upward along each strand of the string. Tension and effort is being applied in the downward direction. Now you have copied the diagram and marked the direction of the tension each. Alright, so you got 1 mark. So what is the second part? Second part, what is the velocity ratio of the arrangement? Velocity ratio is equal to distance of effort to the distance of load. Suppose the effort moves through a distance x in the downward direction. Each segment will get shortened by a distance of x by 2. Alright, you have studied in the pulley section. So what is distance of effort? So this the movable pulley is being supported by 2 segments. So when the effort moves through a distance x, these segments on the pulley, it will get shortened by x by 2. All right. So distance of effort is equal to x, distance of load is equal to x by 2. So cancels, we are getting velocity ratio as 2. All right. So 1 mark you are getting. Okay. Third part. Read the question, don't miss any questions. If the tension acting on the string is T, what is the relationship between tension and effort? So here in this free end, tension is balanced by effort. So I can write effort is equal to tension. Alright, E is equal to T here on the free end of the segment. So again you are getting 1 mark. So no need of writing any detailed answer. The answer should be up to the point. Okay. So the fourth part. If the free end of the string moves through a distance x and the distance, find the distance by which the load is raised. So this case already I have discussed. Effort, free end of the string is moving downward through a distance x. Then the load, the segment supporting the load is getting shortened by a distance of x by 2. So I can write free end of the string moves through a distance x, find the distance moved by which load is raised. Load is raised through x by 2 unit. Okay, x by 2 unit. All right. So you are getting 1 mark. So total 1, 2, 3, 4 marks. All right. So what do you conclude from this session? After analyzing all 2018 and 2019 question paper, the important topic remains same. It's up to you to identify which are the topic relevant, which are the topics irrelevant, and prepare accordingly. Watch the videos, listen to the teacher's instruction, work smart and work hard. You will be successful. All right. Thanks for watching.